Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. This is a problem for today. A company has 5 employees on its health insurance plan. Each year, each employee independently has an 80% probability of no hospital admissions. If an employee requires 1 or more hospital admissions, the number of admissions is modeled by a geometric distribution with a mean of 1.50. The number of hospital admissions of different employees are mutually, the numbers of hospital admissions of different employees are mutually independent. Each hospital admission costs $20,000. Calculate the probability that the company's total hospital costs in a year are less than $50,000. And here's the solution. The company's total hospital costs in a year are less than $50,000 if there are only 2 or fewer hospital admissions for all of its employees combined, because every admission cost is $20,000. So we need to find the probability of that event. 2 or fewer hospital admissions for all of the employees of this company. Also, the text of the problem says the number of admissions is modeled by a geometric distribution with a mean of 1.50. This statement is somewhat ambiguous because a geometric distribution may be defined as the number of Bernoulli trials one has to perform to achieve the first success, or as the number of failures when performing repeated independent Bernoulli trials until the first success. Well, in my humble opinion, the first of these 2 definitions is the standard one, so I'll use it. If P is the probability of success in a single Bernoulli trial, then the expected value of a geometric distribution based on that Bernoulli trial is 1 over P. For example, if a probability of success, P, is 1/3, then on average you'll have to try 1 over P, so 3, 1 over 1/3 equals 3 times to succeed. In this case, 1 over P is 1.5, therefore P is 2/3. And now we look at scenarios that result in the desired outcome, 2 or fewer hospital admissions for all of company's employees combined. There are 4 mutually exclusive scenarios resulting in such outcome. First one is when no employees have hospital admissions. The probability of a single employee having no hospital admissions is 0.8, so the probability of all 5 of them having no hospital admissions is 0.8 to the 5th, because they're independent, so we can multiply out the probabilities, and that's 0.32768. The second scenario is when 1 employee has 1 admission and all other employees have none. The probability of this is there are 5, choose 1 of 5 ways to pick 1 employee out of 5. The probability of 1 employee having at least 1 admission is 0.2, and the probability of 4 employees having no admissions is 0.8 to the 4th. And 2/3 is the probability of an employee having 1 admission exactly, because the number of admissions for a given employee follows a geometric distribution. So 1 exactly means you try once and you succeed, and the probability of success is 2/3. You multiply this out, and this is approximately 0.273066667. Next scenario is 1 employee has 2 admissions and all other employees have none. The probability of that is 5 choose 1, the number of ways to pick that 1 employee out of 5, times 0.2, a probability of 1 employee having at least 1 admission, and 0.8 to the 4th, probability of 4 employees having no admissions. And then given that 1 employee has at least one admission, the probability that this employee has two admissions is given by the geometric distribution with a probability P, probability of success in individual binary trial of 2/3, which means that there is two attempts and success on the second one. So failure on the first one, probability of 1/3, success on the second one, probability of 2/3. You multiply this out and you get 0.09102222. And the last possibility is 2 employees out of 5 have one admission each and all other employees have none. The probability of that is 5 choose 2, number of ways to pick 2 employees out of 5, times 0.2 squared, probability of 2 employees having at least one admission, times 0.8 cubed, probability of 3 employees having no admissions, times 2/3, probability of an employee having one admission, that's the first of the two, and then 2/3 multiplied by 2/3 probability of an employee having one admission, that's the second one of the two. You multiply this out and you get approximately 0.0910222. Since these are mutually exclusive events, we can add their probabilities to get the probability we're looking for, and the total of these 4 probabilities is 0.7827911. That's answer E. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.